So I had a question come in today specifically about motor controllers and how to interface them with the Arduino. And so what I'm going to do is walk you through the process of taking a truth table and turning it into code for the robot. And so this will be able to run your motors. Ideally, a mobile robot will run the motors forward, backwards, left, right, and stop. And I'm going to show you exactly how to translate the technical into code that the robot can read and understand, and that you understand how to do it as well. So what I've got here is the truth table specifically for the L298N motor controller. If you're using a different controller, you're going to have to find that truth table for that because it may not look like this one. And so essentially what a truth table is it tells you in binary, ones or zeros, whether or not something is true or false and how that interacts with the chip. And so this is a lot more technical. Obviously, there's some digital logic behind this, but all you need to know is that reading this table, if there is a 1, it's going to be telling the pin to be high, and if there's a 0, it's telling the pin to be low. And so that's literally all you need to know about this. So we've got ourselves 3 pins, so each motor has 3 pins. There's an enable pin, there's an input 1 pin, and an input 2 pin. And a combination of all 3 of these pins will give us a functionality. And so with 2 motors, we're going to have 6 different pins we're going to have to write data to. So first off, with the enable pin, the motor has to be enabled in order to use it. And so if the enable pin is set to 0 or low, then we won't be able to use it. It's going to be off. So it doesn't matter what input 1 or input 2 is. If the enable pin is 0, it's not enabled. So now we'll take a look at the second row in this table. We've got motor A is stopped. So to stop the motor, we're going to enable motor A, and then we're going to set input 1 to 0 and input 2 to 0. To turn the motor backwards, we're going to set enable A to 1, input 1 to 0, input 2 to 1. To make the robot move forward, we're going to set enable A to 1, input 1 to 1, and input 2 to 0. And we'll be doing this using, like I said, the digital write commands. So like I said, 1 is high and 0 is low. And lastly, there's another command that you can do like a hard stop with, and that's going to be setting enable A, input 1, and input 2 to 1s. And so I'm going to walk you through how to write the forward and stop methods specifically for the L298N, and we're going to be translating the truth tables into code. So as I had mentioned, basically there are kind of 2 ways that you can do this. You can set a high or low value for the input pins, or you can set a speed for the enable pin, and that's going to enable you to move at a certain speed. You get yourself some speed control. So let's go ahead and we'll write this first forward method. I'm just going to call it forward, and I'm going to give it a motor speed. Since we have 2 motors here, because we have dual drive, I'm going to give 2 different speeds. And then I'm going to give it a duration and how long we want this to run. And this is just very simple. We can make this more complicated later, but just to build off of something. So basically, as we've seen, we've got ourselves a truth table. We're going to look through the chart, find our line that says what makes it go forward, and then translate that into a command using the Arduino code. So forward, we have to first enable the motor. So what we can do is do a digital write on the enable pin. So we're going to do enable A, which is this pin right here, so the enable pin for the left motor. And we're going to make that high, and then we can do the same thing for the right motor, which is enable B, and we'll make that high. So that sets the enable pin to 1, which is required as shown in the truth table in order for us to go forward. Then we're going to translate the input pins. So the very first input pin 1 needs to also be high or set to 1. So we can go ahead and do a digital write of, let's start with the left motor. So the left motor is motor A1, and that's the first input pin, and that needs to be high. And what we can do is just grab this line here. We need to do the same thing for the second motor. And that's going to be motor B1, and that's going to need to be high. And these directions are purely based on how you have it wired. So if for whatever reason your wires are reversed, then you may need to actually make this low. And that's just because when you put a motor onto your chassis, it's going to be facing in the opposite direction for either side. So you have one motor sitting like this and the other motor sitting like this, and so obviously the rotations will be reversed. But this will just give you a starting point. What I recommend doing is testing this out and then checking it and then making sure that the direction is in fact the direction you want your motor to be running in. So if you put this robot on the ground when we download the code and it starts spinning, then you'll know one of your directions is off. And it's pretty easy to just change the software to the opposite direction, but you could also change the wiring and just flip the wire leads on the controller. So now we've got one more input to write some code for, so that's going to be a digital write, and that's going to be motor A2, and that's going to be actually low, because that's what the truth table said. It needs to be set to 0. And digital write motor B2, and that's also going to be low. And then what we can do is we can throw in our delay for that duration. And so when we go through, we're going to call this method, we're going to give it 2 speeds and a duration. We also need to set the speed. And essentially what we want to do is assign an analog write to the enable A, and we want to give it a speed of mspeed1, which is our input parameter. So whatever we tell mspeed1 to be, we'll set the left motor to that speed. And this number is going to be 0 to 255. We'll do the same thing for the right side. Again, when we substitute the values in, when we call this method, that'll be taken care of. So that's pretty much it. We translated the truth table for the L298N motor controller to allow our robot to go forward. When you test this out, just make sure that your directions are correct. Like I had mentioned, if they're reversed motors and you have them plugged in the exact same way, in software you're going to have to correct for that. You could also change the wire leads in hardware and not have to worry about it in software. It's really just going to depend on what direction you have the motors mounted in. So now that we have a forward command, I'm going to show you how to create a stop command using the same truth table. So we'll go void stop motors. I'm not going to give it any sort of input parameters or anything. I'm just going to tell it to stop the motors. And so what we'll need to do is there's 2 choices when it comes to stopping. You can keep the motors enabled and do a hard stop, or you can keep the motors enabled and do a soft stop, or you can stop and then disable the motor. So there's a couple of different ways you can go about doing this. I'm just going to do a very simple soft stop and then show you what that looks like. Digital write, enable A, and that's going to be high, and then we'll do digital write, enable B, and that's going to be high. So we've got both the enable pins done. Now we can go ahead and look at the first input pin, and that needs to be set to 0. So we're going to write a low command using the digital write method. Digital write. We've got ourselves a motor A1, and that's going to be low. And I'm just going to go ahead and grab this line. A lot of these lines are very repetitive, so copy and paste can be helpful. And then the same is true for the second input pin. So they're both going to be low. So I'll just go ahead and change the name so that we've got the second input pin. And that's it. So if you wanted to stop the motors and disable them, you could go ahead and you could write a 0 to the enable pin instead of a 1 to the enable pin, or you can contain that in a separate method called like disable motors or enable motors and use that throughout other methods. The idea behind writing these methods is to obviously reduce the amount of lines of code that are repetitive. And so by having like a very simplistic method that you can reuse, it makes it a lot easier when you try to add more complex functionality. So lastly, what we can do is we can call these methods, and what I'm going to do is anything that's contained inside of loop is what will run on the Arduino. So if you don't have anything inside of loop, even though we've written these methods, nothing will work. So what we need to do now is just call I believe we called it forward, and we've got to give it a speed the left speed, the right speed, and how long we want it to run for. So half speed is always a good place to start. And then I like to do like 3 seconds, 5 seconds. So it'll run for 3 seconds, and then we also have to get it to stop. And so to get it to stop, we will call the stop motors. So this is just a little walkthrough on how to use the L298N motor controller. I hope that it makes a little bit more sense. What you do is you take that truth table, you read the lines, you translate the ones and zeros to highs and lows using the digital write command. Do that for the pin for each side of your robot, so left side, right side. And you can control the speed using an analog write command using a value from 0 to 255 because that's the type of output that we have for PWM capabilities. So if you have any questions at all, leave a comment below this video. Hopefully this helps you. If you like this content, be sure to check out the full tutorial on learnrobotics.org.